Climate change is here and is real. Its effects are becoming more visible every passing year, threatening our societies and the future generations. As human impacts on the environment continue to worsen the situation, it is high time to change our policies. To do so, climate knowledge and action must rely on accurate and readily available data. Space technologies and satellite data have been developing over the past decades with a near real-time monitoring of our planet. They are now mature enough to translate into insightful tools for decision makers and citizens. Space agencies, scientists, public and private entities from many countries have gathered together into the Space for Climate Observatory as an answer to the dynamisms and the commitment of the space ecosystem. Since its establishment in 2019 by the President of the French Republic, this initiative has accelerated the development of numerous digital tools to help local population towards climate adaptation, mitigation, and monitoring actions. These applications cover a wide range of environmental issues across the globe, including extreme weather events such as hurricanes and floods, biodiversity losses due to habitat destruction, increase of heat islands in densely populated areas, and widespread tropical deforestation driven by agriculture and logging. As an international network fostering cooperation, it fosters the sharing of knowledge and methodologies. As such, our projects can easily be adapted from one geographical area to another. Since 2022, this alliance is founded on an international charter and is open to broad participation to fully enhance its role. We will collaborate to make satellite data and knowledge more accessible to users. With the Space for Climate Observatory, the space sector rises to the challenge of climate change.
Ladies and gentlemen, welcome back to this afternoon plenary. You've been already emerged to the topic. This plenary is titled Observing the Earth, Serving Our Societies, Space in the Age of Climate Change. Today's panel will explore the vital role of space observations in addressing climate change. As satellite technologies advance, it offers unprecedented insights into critical environmental indicators such as atmospheric dynamics, ocean currents, and deforestation. Today's panelists, representing a very diverse range of sectors and geographical areas, will discuss how data from space is transformed into actionable information for decision makers. And to moderate this session, it is my great pleasure to welcome on stage Laurence Monnoyer-Smith, Head of Sustainable Development of the French Space Agency, CNES. Laurence, please.
Good afternoon, everyone. Thank you very much for being with us during this plenary. As we have been introduced with this film, this afternoon, we will discuss and focus on the key role played by various actors along the value chain of producing of service to users using spatial data. As you're very aware of, space industry and scientific community is mobilized on a daily basis to produce data and services to citizens, to communities, and to decision makers to adapt and fight against climate change. So to discuss these issues this afternoon, I'm extremely honored to welcome during this plenary session, all the guests, you have this on this slide, so please welcome Philippe Baptiste, who is Chairman and CEO of CNES, Simonetta Celli, Director of Earth Observation Programs and Head of ESRI in ESA, Roberto Formaro, Director of Engineering and Technologies Directorate in ASI, Madame Florence Rabier, Director General of the European Centre for Medium-Range Weather Forecasts, Giovanni Silos Lambini, CEO of Planetech Italia, Andrea Taramelli, who's Italian national delegate within the European Commission Copernicus User Forum, and Mr. Michael Ford, who's Chief Scientist for Environmental Satellites within NOAA. We have a wonderful panel this afternoon. So now we are going to, as we're going to tackle the whole value chain of that produce data for service and end users, we're going to start with end users. And I'm going to start the question with our friend within the Copernicus User Forum, because we would like specifically to focus on how Copernicus program meets the main expectation of users in the fight against climate change, and what is the role of Copernicus User Forum? How do we define what we need within the Copernicus User Forum? Mr. Taramelli.
Sorry. So, at European level, at national level, we have set up a scheme based on the regulation of Copernicus, where the users related to climate change can give feedbacks and especially can interact with entrusted entities at European level. Both in this case is ECNWF and also European Space Agency, in order to have sort of like vision and discussion what is the parameters and the indexes that need to be studied and implemented at European level. The good part is the fact that we have a sort of like double vision. The fact that Copernicus is a user-driven approach, it's really important because as we all know that it's important to have a specific and temporal, so a complete temporal analysis for climate variables during time. So the thing that users and the community that we have set up, thanks to the user forum, is really making it clear who is in charge at national level and at European level of the public entities that can have policy and policy implementation related to climate change. So at national level, we have set up a specific working group that is dealing with climate change, essential climate variable and discussion. And we have set up a scheme that which are the primary law at national level that has to take into account climate change in terms of reanalysis, but also, forecast. So in this sense, we are using this National User Forum to discuss which are the main goals that we have to take into account for the national implementation. And then we bring this discussion also to European User Forum level. And we have the discussion with the main entrusted entities, that in this case is ECNWF, and we have set up also some national collaboration program in order to do this discussion. And this is really important because what is sometimes not working properly, if also the European Union is just making framework directive, not taking into account which are the major issues that at national and local level we have to take into account, then you have an evolution of the climate change services that is not completely adapted to what are the real end users. So this is the scheme. So we have a user forum at European level, and we have a national user forum at the national level, where we discuss, and we bring both to the national government and to the European Union, which are the primary needs that has to be taken into account.
Oh, thank you very much. So we're really lucky to have Florence Rabier here with us today, so we can follow on the discussion with her. So what type of services and data are made available within the ECMWF? I need to take a short breath to say that without any mistakes, and to develop those tools. So what types of service, and secondly, how are satellite data integrated directly into your forecasting models? So there's two different steps, what services and how they are integrated, especially to answer to users' needs and questions.
Sure. So at ECMWF, we are operating two climate services on behalf of the EU, the Copernicus Climate Change Service and the Atmosphere Monitoring Service. But we also do weather forecasts for our member states. We have 35 states supporting us. And it all started with our expertise on how we can combine observations with models. So at the moment, every day for weather forecasting, we are using about 100 million observations per day. These are being transmitted from all over the world, in particular thanks to the World Meteorological Organization. And they come from very different sources of information. We use more than 100 streams of satellites coming from different instruments, different platforms. So this is combined with a physics-based numerical model of the planet, so that we can then, from all this knowledge, we can go forward and do predictions for the next days, weeks, and seasonal predictions as well in the context of Copernicus in particular, to plan for agriculture, etc. So this is the weather aspect. But then from this, what we can do as well is run in the context of Copernicus what we call a reanalysis. So it's a bit of a special word, but what it means, we go back in time for decades and we reprocess all the observations, recombine them with the numerical model we have developed for the Earth system, and then we produce a consistent picture of the atmosphere and the ocean, the land, every hour since 1940 to now. This is what we call the reanalysis. So this gives a very consistent view of what the climate is doing, and it's used by many, many sectors. In particular for renewable energy, it's very convenient to know where to put the next wind farms or the next solar farms, etc. And we've just conducted a study recently. It's also not just to know about the climate, but it's really to also have some economic benefits. And in particular, using our reanalysis in Copernicus, we've shown that just the benefits from wind farms, from wind energy, already outweighs the whole cost of the whole program. So that is really just one component, one sector. So yeah, on the slide you can see how the number of satellite streams have increased in time and how we make use of all of them to describe the climate and the future. The last thing I would like to say is that Earth observation is really important in real time, going back in future, but it's also super important to be able to understand our Earth system and to then improve the models that are being used to do seasonal forecasts, but also these climate projections that we do to plan for the future so that we know if we can do mitigation or how to adapt. So observations really come in a lot of what we are doing, and then from there on, a lot of services to the communities.
So what you've just said is that not only do you produce data, I mean, thousands, millions of different data, not only do you reanalyze it, every time you're developing new models or improving your model. So we have here, for example, with us, and thank you very much for being with us, Giovanni Salos Lambini, who's CEO of Planetech, and he's a user, one of the users of these many data. Maybe you can tell us a little bit what you're doing, what is Planetech, what you're doing, what type of services you're producing, and maybe how you're using these data and that Copernicus and ECMWF is producing.
Oh, yes. More than talking about Planetech, I prefer to talk about the important industry that is the downstream industry in Europe that transform data in usable information from end user. We serve with more than 200 professionals, several end users, both in the public sector and in the commercial market. With perhaps a different approach from these two sides, because we produce vertical for agriculture, land management, energy and infrastructure, urban planning, and carbon emission monitoring. And if you look, for example, to the carbon emission, there is from one side the need from government to monitor and introduce this kind of service in the operational activity of government. But on the other side, there is a growing interest in company in manage what is called the ESG, so the environment and social governance of the companies. And we exactly produce using Earth observation data and largely product from SNWF and the other Copernicus activity, this kind of data.
Thank you. So we wanted to insist on the role of defining the needed data in the future. So if I'm coming back to you, Andrea, and how do you plan to involve more the end users to define what will be the needed services tomorrow? And how do we address the future development within the Future of Copernicus program?
One of the things that I think it was already highlighted by Giovanni and by Florence is the fact when we talk about users, we always think that it's, let's say, a unique classification. But if we want to have a real analysis, so we call different type of users. One is the really final end users, like the one that has to make the choice based on the information, not on the data. So this is really important, that the final end user doesn't need the data, needs the information to make the choice. So this is the one that lead the specific requirements. But then we have the data, so we have what we call the intermediate users that allow let's say, the final end user to understand which are the right information that they need and how they can use the information to implement policy. That's why I like the presentation, the slide that Florence was showing, the number of, let's say, satellite data that we are increasing in use in data simulation. The final end user doesn't care about how many satellite data or in situ data are going to be used for the final decision. They want to have the final information. So the thing is that you have to twin the user analysis in like not three separate parts, but in three separate type of users. The one that is represented by Giovanni, so how also much the industry sector can help to translate what is data development, how this data development can be used in terms of translation for the final end user that has to make decision. So we are always underlying in the user forum that this is a joint work. And who is going to deliver the services is not the one that is producing the data. It's very different. So this is the way that we think that the discussion with the user forum, with the enterprise, and with the European entrusted entities has to be stronger and consolidated. This is what we have done also on national level with some national investment, but it's really important not to be confused when you talk to what is the scientific part of the intermediate end user. This is not the final end user. This is someone that really knows about data and help to translate to the final end user. And you cannot make a market if you miss these three different parts.
Yeah, thank you very much. I think what you've said is really accurate, and we'll come back later about this question of how the value chain is building itself in the various countries, because it's not working the same in every country. But I would like to go back to Florence, maybe for a last question. So how do you envision the future? How do you plan to develop and to make the most of satellite data in a near future? What type of tool? What are you building on?
Yeah, so a lot of things, a lot of new tools, in particular in technology, will help us to make more use of satellite information. The first one I want to talk about is these digital twins of the Earth system. So here on the slide, you see planet Earth as seen from a satellite, and on the right-hand side, you can see what we can model at high resolution at ECMWF. You know, from a first glance, you wouldn't know which one is the real satellite image and which one is the one simulated, and this really comes from a forecast. So digital twins, they are really a simulation which is such a high level of accuracy, of resolution, that it has a very high degree of realism. And because of this high degree of realism, you can trust it more, and then you can trust it to plan some what-if scenarios. This is what is being done in particular in the context of the EU initiative Destination Earth. So you can say, what if I planted more trees all over this region? What would it change? What if we would put some reflectance areas? And So this is a very good tool for envisaging what can be done in the future. So definitely digital twins of the Earth. But these use a lot of computing power. We're talking about sustainability. These run on the largest supercomputers in Europe. Another big revolution, which is not common to just our field, but is artificial intelligence. And of course, you know, we've talked about it all over. But for us, machine learning is really something that can complement what we are doing with this big physics-based system. And it's quite new that now we can really do a forecast just with a machine learning forecast or inference, but it is based on all the accumulated knowledge and data, which we have accumulated in particular with the satellites and with Copernicus. But then once you've trained these models on all the satellite and reconstructions from the past, then it runs very quickly and it uses less computer power. So it's a super useful tool. And it's really in its infancy. At ECMWF, we're running one. It's not yet operational, but we already send the products out to users. And actually, a couple of days ago, there was already an article in Newsweek saying how unprecedented quality it was for the tropical cyclone track of Hurricane Milton in the US. So the users are already picking up on it. So I think these two, you know, going to finer physics-based simulation together with artificial intelligence and machine learning will be something we want to combine in the future to make the most of more sustainability and more data. And if I have 1 minute, I would like to say that what really excites us as well in the context of Copernicus is this CO2 monitoring and verification support facility. I think this will be really a game changer. And it will need all our knowledge. It will need new satellites. All the satellites observing greenhouse gases are really useful, but in particular the ones in the context of Copernicus. But then we will also use all our knowledge of the physical system, how the carbon is emitted and absorbed, and also how it's emitted by human people, of course. And this will be another component of where countries can see where their mitigation efforts are, if they are really doing the results as they were expected. Coming from the satellites, we can observe what is going on and in terms of surface emissions, which will be really extremely important in terms of checking what we are doing in the Paris Agreement in particular.
Yeah, thank you. I hope these eyes won't be terrible witnesses of our lack of mobilization, hopefully. I just want to finish this part of this discussion with you, Giovanni. So we've listened to Florence explaining the very innovative tools and that ECMWF is working on. So for Planetech, how do you have started to identify what type of data you will need in the near future? So does this meet with your expectations? Do we do enough for end-user services? So what do you plan to develop as a service?
Oh, yeah. Yes, thank you for this. We like to define ourselves a 30 years old startup. So we changed several times our business model, and we see there is an increasing demand of analytics from Earth observing data, and an increasing demand to have this data with very low latency, so in very short time. For this, we are developing since a few years a concept that in some way translating space design in service, in Earth observation design, what was said a few seconds ago about the digital transformation impact on Earth observation. We are working on the idea of the development of a dedicated Earth observation cloud system in orbit. This will have several important effects in designing a new type of application. Will provide a very low latency and the opportunity also to direct-to-user application, and will make a very big transformation also in the type of user that will interact with us. You know, for downstream company, one of the key points is to look at the user. This was told also by Andrea a few seconds ago. And if the user becomes the machine, we must adapt the way in which we develop our application. So we believe that this will transform the way in which we deliver service both to public and private entity, and we open a more large use of this kind of information in real-time applications that are related both to civil protection and security and in responding to extreme events, but also to implement a more effective operation from commercial entities.
Thank you. So now we've got a glimpse of users' needs, how it is distributed, how hard we are working on new models and new technologies and future services for adaptation and mitigation. But these data, they have to be produced, they have to be financed. And they involve national and international actors, such as space agencies, organizations dedicated to this. So now I would like to go to the second part of this roundtable and to focus now more on the role of the agencies at the national and international level. I'm going to start with you, Stephen, if you would like. You're chief scientist, yes, it's written here, chief scientist for NOAA. And could you please explain to us how NOAA is integrated in the production of satellite data in end users? So we all share the same understanding of exactly what you're doing. And what specific initiative are you putting into place regarding specifically extreme events? We've just been talking about extreme events. We're all concerned about this. So what is NOAA specifically doing regarding this?
Thank you for the opportunity to be here today. So NOAA is unique in the fact that it's both a full operational agency of the United States as well as a satellite operator. So NOAA, on a regular basis, will produce daily weather forecasts, severe storm warnings. It will conduct climate monitoring, fisheries management, coastal resilience, and ensure constant monitoring of the Earth system for our people. So NOAA maintains many processes to understand a confluence of user needs. With such a broad mission mandate, it's important that we understand all of the inputs coming in from all of the users, both local governments, but also individuals that want information. So our processes compel us and influence how we plan our satellite missions, how we construct our ground systems. They inspire our science enterprise, which is a broad science enterprise involving many of our cooperative institutes, which encompass leading universities to drive the science that converts our observables into information that resonates with our users from those engagements. These processes involve many engagements with users, where we strive not just to understand the observational requirement, but the specific way in which those users will apply it. So we have a full understanding as we design our systems on orbit and build the science to deliver those. For severe storms, we have produced a next-generation fire system. So the next-generation fire system meets our objectives to detect and track wildland fires, severely extreme events that happen all over the world. The system blends satellite information with weather information to provide key information that's real-time, event-based, and it provides information to make decisions. That system is specifically designed to be compatible and directly connected to downstream emergency applications. So our user engagement enterprise is guiding us to identify what we need to do in next-generation fire, and as well how to apply it, not only the science and the right information, but to guide that information to the specific users in the way in which they want to use it.
So you're really in direct contact with the end user by even initiating this new application, in direct contact with the end users. That's what you're saying.
Absolutely. I mean, I think not only the user engagements they're not passive.
Yeah.
They create relationships. Those relationships at times will drive our science and development, drive our systems. But we look for and we reach for co-development where the end user, be it a government agency or an individual, is with us as we do it. And that'll ensure that we're hitting the target on each one of the developments that we do and the many products that we do create from our constellations.
Thank you very much. Now we can move to Europe and go to you, Simonetta Celli. Everybody knows you. You're director of the Earth Observation Program within ESA. And could you explain to us what is the specific role that a space agency like ESA is producing satellite data, and especially transforming it into really actionable information for decision maker, because this is the core of what we need today.
Thank you, and good afternoon to everybody. So making sure that the space assets that we have collectively, the national ones, but the European and the international ones from partners, are used, I would say at best, in terms to convert the availability of the information that we have into actionable information for decision makers is essential. It's also part of the core mandate that ESA, being a space agency, has. How do we work? How do we do that? We do it, first of all, looking at, I think we didn't speak too much about that, a science dimension of climate. We have just recently published a new Earth science strategy. We look at gaps in terms of studies, in terms of science objectives that we need to look at. Those are part of the overall user requirements that we need to collect when we define and we plan for new space missions. And that's exactly what we do in ESA. We look at user requirements of various different types. We look at the scientific ones in terms of science gap. We look at those of SABSTA in the context of UNFCCC, so what type of measurements are needed and what type of space solutions can be provided with the infrastructure and the missions that we have to develop. Today, I think worldwide, ESA is in fact at the forefront in terms of number of missions planned and in operations to support climate change overall. And we have meteorological missions with EUMETSAT, we have the Copernicus, we spoke about it already, but we also have the science mission, which are the Explorer missions. And even just today, this morning, we presented as the initial science results of a fantastic mission that's contributing to climate change. It's called EarthCare. We've built it with Japan, and it's a mission that will look at the role that clouds and aerosol have in the Earth radiation budget. How do we do this? We do it understanding the requirements from the science community, building the right satellites, and providing those data to the users. We do this in the context of UNFCCC with a dedicated program called Climate Change. We work with the science community on the climate wearable. We put in common all the available resources in terms of data sets coming from the different free line of action, but also complementing those with the national missions and those coming from the international partners. And we also work very closely in terms of making sure the data quality is the right one, the continuity is the right one. And today, what is very relevant, I think, in the role that an agency like ESA has, is not just the variety of the data offering we have, the volumes, the collaboration which allows to access third-party missions in a mode of collaboration with partners internationally to support the provision of data sets to those who need it. We work a lot with ECMWF. ECMWF uses science data sets from ESA, Copernicus data sets for operational use. They manage the climate service. So I think what's really relevant is for ESA, being an agency, understanding science and operational user requirements from the MET community through EUMETSAT, from Copernicus through the European Union collaboration from the science community, and developing the right mission to support those challenges, giving the right quality data, and also demonstrating the relevance in support of specific thematics. We just spoke about the hurricanes. We also work, and we founded with CNES on the International Charter on Disaster. You know, the last 2 hurricanes happened at 2 weeks apart. 5 hurricanes, and the NOAA colleague will know much better than me, happened in just one season. It never happened. It shows us the trend in terms of increase of extreme weather events. And what do we do there? We have mechanism of collaboration to provide data. And actually this time, for the last hurricane in the US, it was the charter was even triggered by US just before the hurricane happened. So very strong mechanism, I would say, of collaboration through space agencies in support of climate and general trends in the environmental sector.
Thank you for this explanation. I come back to you, Philippe, now. France has always been at the forefront of adaptation and mitigation in terms of fighting climate change. And CNES has led, we've been talking right now about the Charter on natural disasters. CNES has led many initiatives at the international and national level to develop decision makers tools and to develop and enhance contacts with the industry regarding climate change. Can you talk a little bit about it and explain to us?
Yes, well, the first thing I want to mention, I mean, if we want to talk about fighting climate change, the first thing as any organization we have to do is we have to do our own job, which is already to reduce our own carbon footprint when on our daily activities. So this is, I think that all of us try to do that in our own organization, and of course we try to do it too. We have also a specific mission, at least for the space industry, which is located in France, where we basically are asked by our government to really try to improve the carbon footprint and reduce the carbon footprint of the industry. So that's something we do jointly with Airbus, with Thales, and with all the space partners that are located in France. But of course, I mean, it's of course the first step, but I mean, it has to be mentioned because we have to do it. Of course, on top of that, I mean, it's very similar to what you said, Simonetta. I mean, we have to listen to the community to really understand what are the needs. So this is the need of the scientific community on one side, this is the need also of the operational community, I would say, and to basically understand what are the missions that we need to do, what we need to build. And we have to be very cautious also to, in this environment, to be sure that the mission we are designing are missions that are not too much redundant with other existing missions, and that really fill gaps. I think that you use the terms, but that's really essential, that fill gaps for the future, because they either answer to a scientific requirement, because science community needs a better measurement of something, or a new data which is not available today, for instance, or operational requirements that are not fulfilled. On top of making missions, and I'm sure I will come back to that, and we have many nice missions we could talk about. I think that as space agency, we also have, I would say, a duty to ensure that space data are available to all people, starting, of course, I mean, of course, we all know that these data, when they come roughly from space, I mean, are difficult to handle, so we have to put the mechanisms in place, not necessarily by ourselves, but we have to ensure that, I mean, the data are taken care of, that they are easily available, and that they can be translated into applications. Again, it does not mean that we as space agencies have to build the applications. I mean, I wish we could, but I'm not sure that we have enough people to do that. So even if you put together ESA, CNES, ASI, and I mean, so of course we rely on private players, we rely on many people, but it's very, very important to turn these data into application. And in this respect, I mean, the SCO and the Space for Climate Observatory, this initiative is, I think, a very, very good example of what we should do, because we all sit around the same table, space agencies, but also operational agencies of many partners all over the world. I think that there are more than 30 countries that are involved today, 50 signatories, and we all work together to ensure that there are applications that are easily available to all the partners. I think that today we are close to have something like 100 different kind of applications that are available for the different partners. They are locally adapted, so typically one application that has been developed in one continent, it can be easily adapted to another one, and it's a great platform, so to share and to be better together.
Thank you very much. I think we can move to Azi and say, so you've listened how ESA is working, the very strong focus that has been underlined by Philippe on end users and final services and application, how we can, what's the role of an agency to develop that. So what is, how Azi is taking up this role in producing and transforming data? for end users and decision makers.
Okay, thank you. Good afternoon, everybody. First of all, I would like to say one important thing. We have a very wide program in Earth observation. There is a reason.
A bit, can you, speak a bit louder?
Is it now? Okay, okay. So there is a reason why we are investing so much in Earth observation. Our country has a lot of weakness. Many of them are generated by climate change now, which is becoming a very big challenge. And I would like to say that we are fully coordinated in Europe. We have programs. We have a forum like this, the CO, which allow us to be coordinated and work in order to fill the gaps. So this is very important element, and many things have already been said. And we work on three different areas. First is mission. Second is availability of data. We produce data and distribute data. We have to make our best. And the third is support development, application, and services. On the first, our mission are always devoted to solve environmental challenges. We have Cosmo, we have Prisma. Prisma is very important for detecting impact of climate change on our society. That is very important. In the last period, have been complemented more and more by missions that are aimed to solve climate issue. One important example of the complexity that we are going to face when we make our work as agency is represented by a particular mission that is Maya. Maya is a mission we make in cooperation with NASA, and this mission is very complex because it has various components. One component is space, and we have the satellite, but we have also ground-based sensor, the sanitary service of the countries where we have target areas, which will give us data. All the data will be put together and we processed by a community of users that will give us some studies for epidemiological studies and something that will be for the benefit of everybody. This is the way we are going to face in the future. We are more complex situation where space is only one segment of the entire. We are also another good example at national level. We have a similar situation with the Iride constellation. So this is what we do at space segment level. When we go on the ground, on the production of data and distribution of data, we are consulting all the various stakeholders, in particular users, various community of users. We have understood that there is a big demand of data, of preprocessed data. So we have, what we have done, we are developing in our establishment in Matera a laboratory related to Earth observation and integrated application with a particular focus on the Mediterranean area. This is a geopolitical area where everything happens, and the climate is giving a big impact in terms of challenges. And this is the reason why we have activated more lines in order to create a sort of living lab where we will make available data lakes from our mission, from also from Sentinels, from mission, from cooperations, in order to give to the user a more friendly access to data. This is one important point. We have already started to deliver our Map Italy, is a database of observation of our country, may be extended. And the last, I would like to say, we have a dedicated program for application and services. It's a recurrent call, and the 50% of this the contract we assign is for climate change. And this is just to show how it's important this.
Thank you very much. What is really interesting here is that we can see that at the various level, all the agencies are really looking to their communities. You're looking at the Mediterranean, obviously, because it's one of it's under a huge stress. In France, we've been working on cities, on the coastline, because we have a very heavy coastline, and we're measuring, we are focusing on the sea rise level and things like that. And as you mentioned, Stephen, you were focused on fires and you've developed a specific tool. So in the near future, if we look in the next 5 or 10 years, which tool will you decide? How do you decide? How have you decided that you want to develop this instead of another tool? Or how do you listen to your communities, to your stakeholders to say, okay, I want to develop this because it's of tantamount importance for us? So how does it work in NOAA?
Absolutely. Well, we do use the processes to have that constant communication with our users. We also enjoy partnerships around the world with space agencies and other governments that help influence and help us make decisions on what the right move is in a global context. Further, other partnerships, like our partnership with NASA, helps us to embrace innovation and understand where the possibilities are to deliver those important information streams to everyone. One key aspect of helping us making sure that for climate, that we understand and we apply and make the right decisions for climate, is NOAA has adapted an equitable climate services action plan. The specific plan for NOAA guides us to ensure that all of the people around the world and the people that use our information are aware and they have accessibility for that information. It focuses at the local level. So we operate globally, but we also focus the needs at the local level. It injects an understanding of socioeconomic impacts. And it builds, at the same time, and adjusts and reinforces our posture at NOAA to ensure we have the workforce to make sure that this service plan provides equal access to data, both equally observing and equally providing the information to all of our users. And I think a great example of practicing that particular plan was just a month ago. We went to Anchorage, Alaska, and we held the Alaska Next Generation Satellite Workshop. In collaboration with the University of Alaska at Fairbanks, we gathered local communities, executives, scientists, and flight programs to talk about the specific needs that they have in Alaska. And we learned key things. In that particular region and in many regions around the world, access is the first thing to determine and how to figure out. We have incredible assets, but we need to get that to the users. And in many areas, that's quite a challenge. And through many conversations in Alaska, we came up with this impressive understanding of not just what the observation requirements were, but how the local community would access our information, understand the information that we're putting out from our satellite systems, and then make decisions upon them. And that was highly influential and will, again, reinforce our posture for this way to provide climate services to all people.
So you, just to make sure I really understand, this discussion you had at the regional level in Alaska, was it something that you initiated like a while ago? Or is it something you started because you thought that there was specific needs to be met there and you wanted to listen to what they have to, what their expectations were? So you organized that not only in Alaska but in other regions, or is it something very special you've been doing on this, for this community?
So we have access to all the communities to be able to do that, but we do have plans to do that in many places. That format seems to work quite well. And I think it's important to be able to have those types of engagement. The information is quite unique that allows us to articulate our agency, articulate with our partners the right information for key challenges in areas like Alaska, but we would go to other places as well around the world.
Thank you, thank you. So if I go back at the ESA level, so it's kind of a mirror question. How do you ensure that science and operational programs that I provided, that will provide data, remains accessible and relevant for the whole community? What's the process there? How do you grasp it?
Yes, part of the job that the space agencies do, but ESA also does, is to make sure the data are accessible. And they're also accessible in consistent formats, because as we saw here, there's a very strong dimension of international collaboration. Just to mention, no Arctic Center is using Copernicus data. And I mean, really, the collaboration here is very strong. We were also in Greenland like 2 weeks ago, working with scientists from both parts of the ocean, looking at ICESat, the cryosat mission, and showing the relevance of the work done in terms of ice evolution, ice melting, and all of you name it. So the collaboration dimension is fundamental. So what you need to do, two things, and that's part of the job we're doing with the industry in Europe, developing platforms which are relevant for user accessibility, and that's part of what ESA, for example, is doing in the collaboration with CMWF on Destination Earth and on digital twin of the Earth. So we make sure that you have mechanism and infrastructure which allow users and users, no matter if they're scientific or institutional, to access the data easily. The users, they don't care if the data come from a national, European, or another mission. They want to have the data they need. So the platforms that we are developing, and we're actually trying to harmonize all the work that ESA has done in the last years in platforms, in trying to have one set of platform and not 20. We before had thematic platforms, and we now try to really streamline that. And that's an effort we're doing in terms of accessibility, usability of the data, easy accessibility of the data. The standards is also another domain where we're working real hard in collaboration with international partners and in Europe, again with industry. And there, for example, we are developing standards at ESA which are really promoting some standards that are also, I would say, recognized worldwide. And we do that how? For example, through the collaboration we have in CEOS, the committee of 30 space agencies worldwide, where ESA's role has been always to promote standardized data sets and products which have been developed in Europe but can be usable by the entire worldwide community. So developing standards, promoting those standards, and we have in the platform domain a platform, for example, that we've developed with NASA called MAP, which is really making usable, accessible mission from really both sides of the ocean. So the platform and the standardization, I think, are two key elements that we are really working hard on in terms of making the users easily accessing those data sets.
Yeah, thank you very much. I think we have, with CNES and with Philippe, other type of very close link with the end users. And it would be interesting to listen to you how CNES is organizing its specific links with communities, not only academic communities, but also academic communities and different type of end users. Can you explain to us how you're working?
Yeah, it's when you start a space mission, and I would say it's true for Earth observation, but not only. I mean, you have, of course, first to understand what are the requirements, what are the needs of the scientific community, and what are the needs of the what we call operational community. So, and this is really very important, because if you don't listen carefully to the scientific community and to its need, well, you develop scientific missions that are well, not always very useful. And you have also to be careful when you develop your space mission to be sure that you are technically not too much optimistic. So to be sure that at the end you will be able to make the mission, you will be able to make the instrument and try to make it in time, not too late. So this is really part, but sorry, this is really the daily job of a space agency, but it's really to take into account not only the requirements and the need, but also what is available, what are we able to do today? And of course you want to do better than yesterday, but if you are too optimistic or too ambitious, yeah, well, you might deliver for too late. So that's really very important. Then you have to share, and that's something which is very important, because you want to share the data, of course, and I think we all say that, and it's very clear, and the format of the data and the fact that it is standardized is absolutely key. But you also want to share the risk and the cost. Sorry, it's very trivial, but I mean, it's also very important. And this is also one of the reasons why we cooperate so much, I think, between different agencies, because you want to share the cost and you want to share the risk. And this is a very, and also you want to share, and you want also, of course, to share also the technical capacities of the different countries and of the different agencies. And this is all together, this is this whole package that make a mission successful or not. And well, I think we had great success over the last few years. I'm thinking, of course, of the cooperation with the US of SWOT, which is an amazing mission, which provides very, very good and very accurate data on the level of the sea and of the water. So it's an amazing cooperation that we have, but it's also true with CO2 measurements, with Merlin, with microcarb, which is coming, but and also with, of course, with cooperation with our Chinese and Indian partners too. So we really try to put this at the core of our contributions.
Thank you. You've all of you have highlighted the growing need, future need for data to fight against climate change. We're almost at the end of this plenary. If I finish with this last question to Azi, how do you plan to meet these growing needs? How do you collaborate with end users to optimize this data and look into the future? How do you do this?
Okay, I would like just to take some point that Filippa just said. We, in our experience, we understood that what is important is to give the right answer at the right time. This is the point. On environment, on climate change, we need to be fast, very fast. From fast time, we say fast time to exploitation. It's a new word keyword that we are using at ANSI. What we have changed our way we design our mission. We passed from a generational approach to an evolutionary approach. So, and the secret is a continuous and very close cooperation with communities of users and communities of technological providers, not to be ready when the requirements is there and the user consolidate the requirement. In this sense, participation to international forum like this, like GEO, like user forum of Copernicus, we have also a table of national level, is helping us to consolidate requirements in a structured way, and this make our intervention more effective. We optimize our investment. We also are able to coordinate with our partner. We have cooperation with, we work with these, our programs. We have a big national program. We have to coordinate with them. Otherwise, we deliver the same product without no added value. We need to cover fill all the gaps. This is important for us. And this was one of the main changes that we have done. We have generally radically changed our way we conceive the missions. We are applying this on all our system now. One good example, we are making the joint development with ESA, IRIDE, this constellation, which is conceived as a constellation of constellation, is made to evolve, to include other sensors. The concept is important, regardless of the result. The first configuration, we will have first configuration with 8 services. That is important. This service with this constellation will feed services, and then we'll have maybe other additional requirement for joining other services. And one important point, we are creating in our National Recovery Fund this living lab where community of users, institutional, non-institutional, may meet academy, industry, agency, and research institution in order to think about new ideas, new tools for future mission, future application and services. This is the way, and this is something that will be operative in the next 2 years and will be open to everybody. We will invite other agency, university, and we will meet all together in order to design the mission of the future. That is.
Well, thank you very much. We reached the end of this session. Thank you very much. I just have a very quick question to Florence Rabier that is coming from the audience, which is saying, how far into the future can the Earth's digital twin accurately predict the weather? Do you have a very short answer to that so we finish on time?
Yes, so it's different between predicting the weather and predicting the climate. So for predicting the weather, we can do it accurately in the next few days, and then it's sort of anomalies. It's going to be warmer or colder in the next few weeks, and then it's big patterns in the next few months. And then the digital twin of climate that we can do in the next decades. But again, it's not predicting weather, it's predicting its projection of the climate. And this is the digital twin of the climate.
Thank you very much. Thank you to all the panelists. We certainly are very impressed by the way the space industry, community, international agencies, national agencies are collaborating and putting a lot of effort and money, we know that, into trying to help society and to fight against climate change. So big round of applause to our panelists. Thank you very much and good afternoon.